This is Geometry, Unit 11, Lesson 4 on radian measure. When we measure angles, there are two different units that can be used. The one we're most familiar with is degrees. All right, so when we measure a degree, we measure from a horizontal and then up however many degrees we have. 1 degree is 1/360th of the full circle, because there's 360 degrees in a circle. So we're used to using that. So 40 degrees would be 40 out of 360. 50 would be 50 out of 360. 127 would be 127 out of 360. We're used to using degrees. Okay, the other measure you have is radians. 1 radian is the central angle of a circle that cuts off an arc exactly 1 radius in length. So instead of using degrees, we are using the length of the radius as our measurement. So since the circumference of a circle is c equals 2 pi r, and r is the radius, it's actually going to take, well, let's see, if we have a radius here, how many radii is it going to take to go all the way around the circle? Well, it's going to take 2 pi radii to go around the circle. So 2 pi radians is equivalent to 360 degrees. So that means if 2 pi radians equals 360, pi radians is equal to 180 degrees. Halfway around the circle, you would have 180 radii. So if we want to be able to convert between radians and degrees, because we do use both of them, we have to know to go from one to the other. All right, now we got to think about this for a second. We just said that 2 pi radians is equal to 360 degrees, and pi radians is equal to 180 degrees. That's your conversion. Okay, now if we treat this like when we did conversions back in Algebra 1, we start with degrees, and we want the degrees to cancel and become radians. Okay, so if we use this conversion right here, where would degrees go? Well, 180 would go down here. And the radians would go up here. Pi radians is 180 degrees. So degrees cancel degrees, and we're left with radians. Okay, so what did we multiply by here? To change degrees to radian, we multiplied by pi over 180. So if we want to convert 40 degrees to radians, 40 degrees, put it over 1 just to keep it lined up, we know that 180 degrees is pi radians. So degrees cancels degrees. We get 40 pi over 180, which reduces to 9 pi radians. So 40 degrees is 2 pi over 9 radians. Okay, now what if we want to go from radians to degrees? Well, let's see. We start out with radians, and then if we want radians to cancel, we would have to put radians down here. So it would be pi radians is 180 degrees. Radians cancel radians, and we're left with degrees. That's what we want. So we multiply by 180 over pi. So that means, to get that to cancel, the radians would have to be in the denominator. 180 degrees is pi radians. So we want to convert 2 pi over 5 radians, rad stands for radians, to degrees. 2 pi over 5. Okay, so since this is in radians, we want pi to be down here, is 180 degrees. Radians cancel radians, and actually the pi's cancel the pi's as well. So this is going to be 2 times 180 is 360 over 5, which is equal to 72 degrees. So there we go. We've converted it to radians to degrees. Now, radians don't always have a pi in them. You can also have 1.74533 radians to degrees. We do the same thing. 1.74533, put it over 1, just keep it lined up, times pi down here, radians, over 180 degrees. This is in radians. Radians cancel radians. Multiply these together and divide by pi. This comes out to be approximately 314.1594. over pi, and then you put this in your calculator, and it comes out to be approximately 100 degrees. Okay, so degrees to radians, you multiply by pi over 180. Radians degrees multiplied by 180 over pi. You want to get the units to cancel and have the ones left over. These two formulas are on your reference sheet, so you will have them, but you do have to know how to use them. Okay, now that we know how to convert between radians and degrees to radians, we can apply this to figuring out values about sectors and arc length that we did in the last lesson. So in a circle of radius 12 miles, find the length of an arc subtended or intercepted or cut off by a central angle of pi over 4. Now notice that this is pi over 4. That means that this is going to be in radians. So if we are using the angle in radians, we also have to have the other units also have to be in radians. Any other angle that we use has to be in radians. Okay, so let's draw the picture that goes with this. First thing I'm going to draw is myself as a circle. Here's my circle. The circle has a radius of 12 miles. So this is going to be 12. Find the length of an arc subtended by a central angle of pi over 4 radians. All right, so pi over 4 would be the measure here. That's in radians. And we are looking for the arc here. Okay, so we're looking for the length of this arc. This is going to be part to whole. Okay, now, since we are going to use the angle pi over 4, the part would be pi over 4. What would be the whole? So pi over 4. Now, it's going to be 360 degrees, but we want this to be in radians. All right, so the whole 360 degrees, remember, is 2 pi radians. So we would put 2 pi here. Part, whole. The central angle compared to the whole. Okay, equals. All right, now if we're looking for the arc length, that would be S, as part of the whole circumference. Remember, that's 2 pi r. Okay, now, when we set up this ratio, what do you notice is the same in both of these? This is 2 pi and this is 2 pi. So can't we cancel those out? Because we're going to be multiplying by 2 pi, then dividing by 2 pi if we cross multiply. So that cancels that out. So that leaves me with S equals R times pi over 4. All right, now what is R? R is 12. All right, and S is going to equal 12 over 4 is equal to 3 pi. And then we want to figure that out into the nearest hundredth, say. We will put 3 pi in our calculator. So I get out my calculator, and I calculate 3 pi. And we get about 9.42. So the length of the arc is 9.42. Okay, so make sure when you do this, oh, it's in miles as well, because this is in miles. Okay, make sure if this is in radians, this has to be in radians. Okay, you have to use the same units. You can't use radians and degrees. It doesn't work. You have to do the same units. In a circle of radius 32, what is the measure of a central angle that subtends an arc of length 6? Okay, so this doesn't say which way to do it. So let's pick out both of them. All right, so let's do this in radians first. If I do this in radians, the set of the radius is 32, and the arc length is 6. So I'm drawing my angle, whatever it happens to be, my arc length is going to be 6. Okay, now if I do this in radians, I'm looking for the measure of the central angle I'll call theta. Theta over 2 pi, because it's in radians, is equal to the arc length 6 over 2 times pi times 32. 2 pi r. Okay, now notice here, 2 pi and 2 pi will cancel, because you would multiply and then divide by 2 pi. If you cross multiply, it's going to cancel it out. So that gives me theta is equal to 6 over 32. And just put that in your calculator. 6 divided by 32, and you get 0.1875. So this is 0.1875 radians. Okay. Now, what if we wanted to do this in degrees? Well, it would be theta over what would be the whole 360 degrees, if it's in degrees. And then the same thing here, 6 over 2 pi times 32. Okay, so cross multiply, you end up with, this actually works out to be 64 pi times theta is equal to 3060 times 6 is 2160. So to solve, we have to divide by 64 pi. Don't forget that has to be in parentheses when you put it in your calculator, or it'll give you the wrong answer. Go to your calculator. 2160 divided by parentheses 64 pi. And you end up with 10.74 approximately. So that angle is approximately 10.74 degrees. So you can do it with radians as long as this is 2 pi. You can do it in degrees if this one's 360. Find the area of a sector of a circle of radius 12 millimeters having a central angle of 3 pi over 8. Okay, so if I draw my picture here, here's my circle. The radius is 12 millimeters. And the central angle is 3 pi over 8. Is that in degrees or is that in radians? Well, if there's nothing there and there's a pi in it, it's going to be radians. So whatever that's going to be is 3 pi over 8. Okay, so let's figure out what the area is. All right, for the angle, it's going to be part 3 pi over 8 over the whole. Since this is in radians, the whole would be 2 pi. Equals the part of the area, that's what we're looking for. We're looking for the area of the sector, which would be A, over the area of the whole circle, which would be pi r squared. And it's going to be r is going to be 12. Okay, so doing a little multiplying here. Again, both of these we would be multiplying and dividing by a pi, so the pi will cancel on this and this. Okay, and so that gives me 3 pi over 8 times, this is going to be 144. 12 squared is 144. I'll put it over 1, just keep it lined up, is equal to 2a. All right, if I multiply this out, 3 times 144 divided by 8 is 54 pi is equal to 2a. And then divide by 2, a is going to equal 27 pi. So 27 pi radians is what this is going to, or excuse me, millimeters squared. So if we want to change this and to figure out what it is, you take 27 and multiply it by pi. And you get 84.82 square millimeters is your area. Okay. All right, let's do one more. A circle has a radius of 21 inches. What is the central angle of the sector having an area of 350 square inches? Okay, draw my circle. All right, and I have a sector drawn in my circle that has an area of 350 square inches. So I don't know what this angle is, but I know that the area is 350 square inches. Okay, we're looking for the angle, and the radius is 21. Okay, so again, we can do this in degrees, or we can do it in radians. Let's do it in radians. All right, so it's going to be for radians, it's going to be theta over 2 pi, because this is in radians, this is going to be in radians, equals the area of the sector, 350 over pi r squared would be pi times 21 squared. Okay, so this is theta over 2 pi. Again, the pi's can cancel out because of the both pi in the bottom here. Okay, so it's going to be theta over 2 is equal to 350 over 21 squared is 441. So we get 441 theta is equal to 700. And divide by 441, and 700 divided by 441 is approximately 1.59 radians. Okay, so that is radian measured.